This server rack is rapidly overheating. While it looks like the result of a massive outside attack, this system is actually being brought down by a single user clicking through a standard front-end dashboard. On the client device, the interface appears to update seamlessly, but behind the screen, a catastrophic silent failure compounds with every navigation. These metrics track the damage in real time. On the left, client memory steps up like a staircase with each click. Simultaneously, back-end CPU spikes, struggling to process redundant queries for abandoned pages. The central mystery is why simply moving between views creates this simultaneous client-server meltdown. Many developers assume that unmounting a component inherently stops its pending operations. In the JavaScript runtime, that assumption is false. Building production-grade applications requires managing the lifecycle of the event loop itself, utilizing a unified cancellation primitive to protect system resources. Whether using React, Vue, or vanilla.js, unmounting a component only removes the HTML element from the visual DOM tree. Underlying asynchronous operations, like a heavy network fetch or a repeating timer, remain active, remaining entirely decoupled from that visual element. Hiding a UI element while a data fetch is still running creates a completely orphaned ghost process in the background. It continues consuming system cycles with no interface left to receive the result. JavaScript execution is built on a single-threaded call stack, processing only one function at a time. When you invoke an asynchronous operation, like fetch function, the engine delegates it to the browser's web APIs. Once delegated, this web API thread operates independently of the main JavaScript thread. When a UI component unmounts, there is no native signal to tell the web API that the task is no longer necessary. The web API eventually completes the task and pushes a callback function into the macrotask or microtask queue. The event loop eventually moves this orphaned callback back onto the main call stack for execution, regardless of whether the original UI still exists. The delegation model ensures that unmanaged tasks will always execute to completion, even when the user has moved on to a different context. JavaScript's garbage collector uses a mark and sweep algorithm. It only reclaims memory when objects are no longer reachable from the application root. An orphaned callback sitting in the task queue contains closures, direct memory references to variables from its original unmounted component. Because the event loop holds a reference to the callback, and the callback holds a reference to the component variables, the sweep algorithm cannot delete that memory. This unsevered reference chain is the exact mechanism behind the staircase memory leak seen in the dashboard. A common but flawed approach is to track a Boolean isMounted flag and simply suppress the UI update within the callback. This only hides the problem from the user. The backend is still spending compute cycles calculating a response for a request that has been abandoned. The modern solution utilizes the AbortController API. You instantiate the controller and pass its signal directly into the fetch options. This signal acts as a communication tether between the component and the web API's network layer. During the component's unmount phase, the developer calls controller.abort. This command actively severs the network connection. The promise rejects immediately, preventing the callback from ever reaching the task queue. Aborting the request stops wasted work on the backend and allows the garbage collector to reclaim the local closure memory. This same logic applies to DOM event listeners, replacing the manual removeEventListener pattern. Manual removal is fragile because it requires keeping an exact memory reference to the original function, often leading to complex state tracking. Modern AdEventListener implementations can natively accept an abort signal in their options parameter. You can pass the same abort signal to a network fetch, a timer, and multiple event listeners simultaneously. A single abort call instantly terminates every connected operation. This eliminates the need to track function references or manage internal Boolean flags for cleanup. AbortController provides the native, unified mechanism for declarative resource cancellation across the entire runtime. Returning to the dashboard equipped with an AbortSignal architecture, the telemetry tells a different story. The client memory usage remains flat because closures are destroyed the moment the user navigates away. The backend avoids lockups because the server halts database queries as soon as the connection is dropped. Managing these life cycles ensures that client-side logic remains synchronized with backend resource consumption, preventing the leaks that destabilize systems at scale. Review your current codebase for unmanaged life cycles. Look for any orphaned async callbacks, pending promises, or manual removeEventListener logic. Consolidate these disparate cleanup mechanisms into a unified AbortSignal architecture. In production environments, leaving orphan tasks active is no longer an acceptable practice. Controlling what happens after a component disappears keeps the event loop pristine, protecting both the backend and local system resources.